indexes and logarithms. And this video we will separate it into two different parts. Part 1, we will deal with indexes. This is on our part 1. And part 2, this is our part 1. And part 2 will be the logarithm. Part 2 will be logarithm and the law of logarithm. This video is also included in my blog, free the stuff for all sport. You may want to log into it, and you have a list of video. Now start with our part 1, which is indices, and also we're going to deal with law of indices. Now what we will learn is first of all, it will be a positive index, or an index form of a number, says index form. Index form of a number will be normally as a power n. A raised to the power of n, where n is the indexes, where this n is the indexes. Part 1, we're going to find out what's this number, or what's the whole number. Now suppose we have a number, example form. I will just dive into an example. Say you were given says -3 power 4. So what it means, it is actually -3 times 4 times of it. 3 times -3 times -3 times -3. I think by now the users should be able to use a calculator to perform this kind of calculation, or you just key in as it is, power to the raised to the power of 4. The answer should be 81. Simple. Index form. A number, it could be in a fraction, but the concept is n is the number of times. So here we have 1, 2, 3, 4. 4 times. Simple. It's a kickstart. There are sometimes we will have negative indexes. What happens when the number becomes negative? This is our first form, factor. Next we will have maybe part 2. Oh, I'm missing n. Part 1. Part 2, we have negative indices. This is a time where you have a negative n. It's a negative number. Now, what does it mean by negative number? It is when it is at a fraction. Oh, sorry, it's not a fraction. It's 1 over. Will be equals to 1 over a power n. Or is also equals to a0 over an. Because what happened, it is a0 minus n. So therefore it's basically a negative n. That's the concept. Therefore a negative n is here. So this is the essence. The way that you need to use my video is you need to rewind it back, download it, rewind it accordingly if you have missed certain part. Say for example, I have a fraction, says now I have a fraction, there's a green smaller number, a smaller tip, -3, let me not use a negative number, so confusing. How about 3 over 4? Whole number raised to the power -2. So the answer would therefore be equals to When it's negative, it's 1 over 3 over 4. 2 times. Which therefore be equals to 1 over 3 over 4 by 3 over 4. And the answer, if you have a calculator, you put in a calculator, the answer is supposed to be, you invert it, it turns out to be 16 over 9. This should be the answer. Okay, I'll leave it to you, user out there. For more exercise, you're supposed to do more exercise. Practice makes perfect. But once you get the concept, you may proceed to other question already. Third one. Would be also, third one we will deal with fractional indices. Fractional indices. What happens when it's a power 1 over n. N root of a, it turns out to be. N root, square root of a. That's the concept. Whereas, what happened when, well, let me give you an example. These are the law that you're supposed to know, so an example. How about, let's take a number, says, I have, 64 and a half. Or also is equals to 64 and a half. And that's basically square root of 64. And the answer would be 8. Or maybe I will use, this is a very simple concept. When it's 1 over 2, it's 2. If it's 1 over 3, so it's 3. Okay? The fourth one, the fractional indices, the fourth fractional indices would be a combination. A m over n turns out to be, well, this is n square root of a times power m. Now, this is a combination which is also equals to a power m and then square root of n. Okay, I'll give you an example. The first part of indices in chapter 5 is rather simple. It says I have 27, maybe 4 over 3, 4 by 3. No. You thought it's a 27 power 4 over 3. Okay? So this one will be easier if I were to square root 3 of 27. Then I get a power 4. This is actually 3, the answer, by 4. And then the answer turns out to be 81. You may of course get the power 4 of 27 and then square root of 3, but that would be a very huge number. So might as well make it small by first get the square root 3 of 27. This number becomes smaller, and then you power raised to 4, power 4, then you get an answer easily by performing a mental arithmetic. But then of course you may have some other instances. Maybe I'll give you another instance. Says a negative fractional form, 16 over 625 raised to the power of negative 3 over 4. So a negative number would therefore be equals to 1 over 16 over 625 raised to the power of 3 over 4. First line will be to simplify it, and then next line will be simplified further. 1 over here, I would say is I want to make a square root 4, 16 over 625. Then only I power by 3. The answer would therefore be 1 over 2, 3. This is 2. This is 5. Raised to the power of 3. And then put in calculator, the answer is supposed to be 125 by 8. So the answer. Okay, I hope you enjoy this first part. Section 2, next, we're going to deal with the law of indices. Now, when it comes to the law of indices, we have how I'm going to perform operation. There are total Section 2 law of indices. Now please keep in mind, in order for the indices to work, one thing you need to know for sure is when a power 0, that's basically equals to 1. And a can never be equals to 0. This condition is true. Otherwise, there's no solution. First law, I will start with multiplication. Same base number, this is a base number, am raised to the power, times same base number raised to the power n. The base number has to be the same. The indexes is different. You perform operator times operation, and therefore equals to a power m plus n. Simple. Let me highlight all the operator before we go to the exercise later. First one, second one. So this is equal. What happens if am, you have multiply, you have dy, a or n. The base number remains same. When it's dy, then there will be m minus n. Or in another form, it is also equals to am over an. This is straightforward, pretty straightforward. And this condition a cannot be equal to 0. Now the third one would be am power n will be equals to am times n is mn. Tree law. You may of course have another form says what happens when your base is not the same. Let me introduce it to the fourth one. What happens if you were to be an, you times bn. The base is different, the integers is the same. Simply you times the base number to the power n. And of course, what happened? The fifth one, the base is different, the integers are the same. is actually A over B, same power. Now I'll give you an example in the next page here. Maybe I'll use this weight. First example, well, question 1, 4 power 7 times maybe 4 power negative 2. Eventually, the answer would be equals to 4 power 7 plus minus 2. 7 minus 2, therefore, is 4 power 5, 4 to the power of 5. And you need to get the answer, put in a calculator, is 1024. Users are supposed to know how to use your scientific calculator to get the answer. Second example, pretty straightforward. What happened when you have 3 power 6? Now divide 3 power 4. It turns out to be 3 power 6 minus 4, which is 3 power 2, turns out to be 9. This is for your own practice purpose, so I would not expect this kind of question will come out in the exam. You should make more exercise, do more exercise. Let's say the fraction by 8, so this is m is half, n is 8, so you need to times it in, straightforward, 2, 1 over 2 by 8, so 4, 2 power 4, answer will be 16. It's rather straightforward. And example for different base number. Say you have number 2 power 3 times 3 power 3. What happened is the answer will be straight away 3 times 2, 6 power 3. You get the answer, which is also, this answer should be the same as with 8 by 27. If you get a calculator, you are supposed to tell that this number would be equals to 216. 8 times 27, 216. Different base, same indices, you times the base number. And the same goes with this question. 5. I have, says, maybe 5 power 2 over maybe 9 power 2. The answer is supposed to be 5 over 9 power 2, which is equals to 25 over 81. This is the second section of part 1. You get to deal with little more exercise. You deal with indices. Then part 2 would be more challenging, logarithm. Before we proceed to the next part, let's look at some of the past year SPM style question. Normally we're giving an example like this, a question that involves the law of indices. Example, real-time example, says you have 3 power 2m minus 2 by 27, maybe over 9m minus 2. You realize the tutorial question, the online lecture given is so simple. When questions comes in, it becomes so complicated. Don't worry, they are related. It's just that, first of all, you should be able to simplify the question. In order to start out with the solution, to relate what you have learned earlier, all you need to do is you simplify this number 27 and 9 and look for relationship between 3 and 9 and 27. What's their common factor? Indeed, it's 3. 3 is their common factor. So if you doesn't know how to start with, look for the common factor. What do they have in common? 3, 27, and 9. It's 3. You only know it once you have do quite lots of exercise. So once you have simplified it, so you know it's 2, 3m. This is already the simplest form. 27, in order to get 27, that will be a product of 3 power 3. Sorry. 3 power 3, 27 over, in order to get 9, this is 3, 2, this is m minus 2. Okay, gives you a few seconds to look at it. Then this is what you have learned earlier. The previous online course I taught you. I will show you. Then this is the law of indices. Times is plus. So turns out to be 3, 2m minus 2. This is times is plus 3. Over, this is 3. This is m and this is n. So you just times in accordingly. Maybe a arrow. This is here to here. This is here to here. Therefore, it will be 2m minus 4. Once you simplify those numbers, make use of the law, and eventually you solve this. That would be 3, 2m plus 1. This is dy. dy is minus. You subtract 2m minus 4. You should be good at using bracket. Otherwise, you have missed out the sign. The sign went missing. So you times it in. Therefore, the answer is supposed to be 3 power, what? This is this is plus 1, sorry, positive 1. So negative into positive 5. This is here to here is cancel. This is power 5. And therefore the answer is supposed to be 2, 4, 3 if you have a calculator with you. Quite easy done. Now, let me pick another question over the next page. Says another past year question like this. We have square root of 9 x by minus 2 square root times 81 x plus 1. Again, first line, you can't use what you have learned in the previous page. You need to first simplify. First line is to simplify these two numbers, 9 and 81. Common factor is 3. So you simplify this number and look for what we have in common. They are related by 3. These two number. Common factor is 3. Lowest common factor. You should be good at it by now. So this one is 3, 2. So I would say maybe it's 3 power 2, 2, 3, 9. This is x minus 2. This is 1 over half. Square root is half. Then this is my times. In order to get 81, it's 3 power 4. 3 power 4. This is x plus 1. I can show you here that once you simplify the number, look for the common factor, simplify it, then the working should be quite straightforward. This is times it in. 2 and the 2 can be cancelled off. It will turn out to be 3 x minus 2. Here it times in 4x plus 4. Plus 4x plus 4 is plus because of multiply. Maybe use some guide. This is 1 over 2 can be cancelled off. This is plus because of times. Because of this times, you get plus. You times it in 4x 4. You need to times both number. You just don't just by 4x. It's 4x plus 4. Then you have some time to look at it. Simplify it. 4x plus x is 5x. Minus 2 plus 2 is plus 2. So this is the answer. Unless you will know you were given with x, otherwise this is the final answer. So I'll leave you with that. Part 2 of chapter 5 will be a logarithm. Kindly look for my second part 2 video from 5. And before you dive into part 2, I hope you have done sufficient practice on Law of Indices. Otherwise, it will be so heavy when it comes to with log. See you next video.